Okay.
Please share.
So. All right. So. What have we been doing? Partying? That's great. Oh, in this one. Quadrilateral. What about quadrilateral? What stuff?
The characteristics.
What kind? Characteristics of what?
Parallel.
All right. Give me one.
The consecutive angles.
Okay. Consecutive angles are?
Supplementary.
Okay. Pass it off to somebody else.
Sorry.
Here we go. Up. Give them the ball. Whatever you guys do.
I throw in the ball.
Yep. Another.
Both pairs of the sides are.
Okay. Pass it off.
Sorry.
One that's not named.
Opposite sides are congruent. What pairs of opposite sides are congruent?
You said.
Like to pay attention. That's what he just said. Try again. Now you gotta give me two. I'll help you out.
What pairs of opposite angles are congruent?
What?
Both pairs of opposite angles are congruent.
Okay, show off for Mr. Marks. That's one. What's another one? Come on, you're on spot.
Diagonals.
Diagonals do what?
Diagonals make two congruent triangles.
All right, I'll give you that one. Throw it out. You know, there are females in this bunch. Boys are around the time.
Diagonal lines bisect.
Wait, I'm sorry.
Diagonal lines bisect.
Reword that.
Both diagonal lines.
Take out the line.
Both the diagonals bisect
Bisect what?
each other.
Good. One more.
That one.
All right. Did we get all six?
Yes.
Take a shot. Come on, you're the closest one.
She misses.
Slam dunk.
All right. Okay, so yes, we had 6 important facts about a parallelogram. Those were the ones. Both pairs of opposite sides congruent. Both pairs of opposite angles congruent. Consecutive angles are supplementary. Both pairs of opposite sides are parallel. Write this down so I don't have to try to do it at one time. 6 facts. I should have written this down as you're writing them. Ricky, you're the first one. Give me one. Which one are you going to do six? Consecutive angles are supplementary. You threw that off to here. You said
Both pairs of angles. Sides are.
opposite sides congruent, and then went from here to here.
Diagonals create triangles and opposite angles are both pairs of opposite angles.
Triangle and opposite angles are congruent. Then you throw it back over. All right. Which one was the one that you said?
Both the diagonals bisect.
Diagonals bisect each other. And then you passed it off to Emma. Emma said what? Their opposite sides are parallel. Okay, very nice. Those are the 6 important facts. Those are the ones that we did the other day. Now, once we did the 6 important facts, then we stepped that up a little bit and said, okay, now we're going to go the opposite way. And we did what?
5 ways to do it. Multilateral is a parallel.
Okay, 5 ways to prove a quadrilateral is a parallelogram. So, who's got one? Here.
Both pairs of segments are parallel.
Let's see. Prove both pairs of opposite sides. You said parallel. Okay. Pass it off. Somebody else. Doesn't matter.
Prove at least one pair.
Take that out.
Prove one pair of opposite sides. Both are
Suppose it's going on. They're going to be going back and forth all the time. So, prove one pair of opposite sides
are both parallel and
is both parallel and congruent. Pass it off.
You wanted it. I think you wanted it. You wanted it.
Come on, Marty, what do you got? We got both pairs. Prove that both pairs of opposite sides are parallel. Prove that one pair is both parallel and congruent. I'll give you a hint. Look in here. You can probably gather it. What about how many? Both what? Only two? Both pairs. So prove both pairs of opposite angles are congruent. That's 3. We are 60% done. Pass it off. What did you guys all do this year? Nobody wants to throw over here. What do we got? You're going to be the
Pair of opposite sides.
prove both pairs of opposite. Prove both pair opposite sides congruent. Okay, pass it off. This side of the classroom somewhere.
Please.
Here we go.
Pass it there.
There we go.
Whoa.
All right, here we go. Last one.
Diagonals bisect. Prove that diagonals.
Prove that one bisects the other one.
Both diagonals bisect.
Prove they both bisect each other. Prove diagonals. Oops. Okay, very nice. Prove that the diagonal bisect each other. That's the last bit. Those are the 5 ways. Now, we went through some things and we had some homework. Yes? Okay, get that out. Are there any questions on any of those before we move on into what we have?
A few. The last question, like I went home and did it, but like, what's really easy? I was just thinking, what is easy?
You could have done it in your notebook, you could have done it on the paper. Really, it doesn't matter where you do it. Are we okay on all of these? We went through the first page. So it's really only the ones that are on the back of the first.
What was the? Did you do the last one?
How about that one that's under number 33? What are the coordinates? Ladies and gentlemen, what are the coordinates of the intersection of the diagonals of the parallelogram ABCD with those vertices?
Negative.
How do we get that? Negative what? What do you have?
Negative 1, 2.
Negative 1, 2 over 5. Do we have any?
No, 5 over 2, 5 over 2.
Oh, dyslexic action. Okay. 5 over 2. Do we have any takers on this? Do we have any people that agree? Anybody disagree? Anybody get something different? Everybody not know how to do this problem? Well, when you find it, let me know how you did it.
I got 3, 5.
3 and 5 of them. This is the one that's not numbered. It's the one numbered like 31 or something like that. 3 and 5 halves. Any other?
I got the 3 and 2.5.
3 and 2.5, okay. 3 and 5 halves. All right? Anybody not get this because they didn't know how to do it? Be honest. All right. So, somebody give me Ricky. No, you're not looking at the problem. Emma, so your paper. Oh, I didn't know you were looking down. So, sorry, Emma, give me the coordinates for point A.
Oh, it is.
It are. This one and this one.
For the one that's not numbered.
Okay.
For the coordinates, yeah.
A, 2, 5,
2, 5, B, 6, 6, C,
4,
4, 0, D,
0,
0, negative 1. Okay, now, we were looking for what? What was the question? The point of intersection for the what?
Oh,
Okay, so the point of intersection
No, it is 3 over 2.
for diagonal. Okay, paraphrasing. So find the point of intersection, find the coordinates of the point of intersection for the diagonals. How would we do this?
Oh,
We got rock. We got
Rob says you must find the midpoint of, you must like find the midpoint of diagonals and where the intersect. That's find the midpoint of both diagonals.
I gotta find the midpoint of both diagonals, he said. Is that accurate? Is that accurate?
Oh, yeah, yeah.
So I gotta find both of them? Think about what you just said.
You can find midpoint of one, which I do diagonal.
Why do I only have to find the midpoint of one?
Because they bisect.
They bisect.
Oh.
If they bisect each other, where does the segment get bisected?
I wish
Same.
It's midpoint. Well, that means the midpoint of one of these diagonals is going to be the same as the midpoint of the second diagonal, is the other diagonal. So I don't have to find both midpoints. I can get away with only finding one. Now, problem is, where are my diagonals? What is going to help me figure out where my diagonals are? Yeah, giving myself a little bit of a diagram. So, if I give myself a little bit of a diagram, okay, I have positive and negative numbers here. So we're looking at the point 2, 5. 2, 5 is going to be somewhere around there. 6, 6, that's going to be somewhere around in there. 4, 0, that's going to be somewhere down there. And 0, negative 1, that's going to be somewhere around in there. Okay, now, when I sketch this thing out, now I've given myself a visual of where my potential diagonals are. Because I do not want to go in alphabetical order because I am a mean old man. I will mix those up on purpose, intentionally. Okay? So please do not ever go by alphabetical order. Alphabetical order means nothing in mathematics. Okay? So don't do it. Now, so we take a look at this. Where are my diagonals?
AC and BD.
What?
Segment AC and
Segment AC and segment BD. Which one do I need to find the midpoint of?
any of them.
Give me one.
Segment AC.
Fine. Find the midpoint of segment AC. How?
Use the midpoint formula.
Which is?
X1 plus X2 over 2. Y1 plus Y2 over 2.
Yes. Average X, average Y. So, what are the X values for segment AC?
2 and 4.
2 and 4. So we got 2 plus 4 over 2. What are the Y values?
5 and 0.
5 plus 0 over 2. Well, what's 2 plus 4? 6. 6 divided by 2. 3. 5 plus 0. 5. 5 divided by 2. Does 2 go in evenly into 5?
No.
Does 2 go evenly into 5?
Yeah, but it has to.
No.
That's
Evenly.
Leave it alone. Okay? Now, I know that it goes in, and you can say, okay, it's 2.5. There's no rounding error. But what happens if it was 5 over 3? What would you all have probably done?
just leave.
Well, you probably would have been like 1.67.
Yes.
Yes. All right? Don't do that. 1.67 is an approximation. 5 divided by 3, 5/3, that's an exact value. It's perfectly okay that we have improper fractions. You're no longer being assessed whether you can take an improper fraction and convert that into a mixed number. As a matter of fact, I'll never ask you. Okay, that is topics that we had to do a while back. Now, this is an exact answer. It is an exact answer that we are okay having. And we are dealing with slopes, and we're dealing with radicals, and we're dealing with, in this case, midpoints, and everything else. We need to be able to look at exact values. Okay? And fractions are okay. As a matter of fact, they're perfect when dealing with slope. We want fractions. They're easier to work with fractions. Okay? So leave that there. Yes, ma'am.
Out of curiosity, how come in math, like we always keep our slope as a fraction, but in biology, this kind doesn't accept fractional ones?
Well, because I'll tell you, science, they do their own thing. They want to think that science is separate from mathematics, so they throw in their own little rules. There is no separation between science and mathematics. Science is the application of mathematics. We gotta make them feel good and say, you know what, you gotta have your own way. Same reason she calls this
Yeah,
a line. That is not a line.
That is,
That will never be a line.
those are line segments.
Okay? These are segments, or if you want to have the word line in this could be a broken line. I don't really like that. But this is just a curve, okay, of some sort. Okay? It is a graph, right? But that is not a line. That's like saying this is a line. Okay?
that's a line of best fit.
A curved line. Well, being that a line is a set of points that extend in opposite directions forever, there cannot possibly be a curved line. Which makes no sense why we talk about your elementary school teachers get in a straight line. There is no other kind of line. Okay? Kind of being redundant. Sit down, sit down. Okay? Sit down, sit down. Stand up, stand up. Why are you repeating yourself? Well, get in a straight line. Why are you repeating yourself? Okay, there is no other. There's no need to be there. Right? Great question. Part of the reason that they like to do it, scientists also like to deal with significant figures. Okay? They have a very, I shouldn't say they have a hard time. Outside of saying significant figures, scientists don't like anything else. Okay? Scientists are very much into significant figures. Their whole life revolves around sig figs. Okay? Mathematicians, pure mathematicians don't care really so much about the sig figs. They deal with the theory and the principles behind the significant figures. Those sig figs work or change with each problem. This stuff doesn't change between problems. The only thing that changes between the problems are the significant figures, are the numbers. Okay? But this process doesn't change. So in a nutshell, just a difference of opinions. Okay? All right. So we found this. Do I need to go back and find the other one?
No.
No, because I know from right here that the diagonals bisect each other. So if I know that this thing was already a parallelogram, I know that this fact is true about it, so I don't have to go through this. Did anybody else find a different way? A much longer, much more involved way? No? Awesome. Okay? Because some students in my other class did. Okay? And it's perfectly fine. I was actually hoping that somebody would have done that. All right? I am perfectly content that you did not do it, though. You're working smarter, not harder. But if I'm looking for the point of intersection, what did we do last unit? What did we do last unit when we looked for the point of intersection? System of equations. In this case, I'm looking at the point of intersection for my diagonals. How many diagonals do I have? 2. So I would do what? I could
Elimination of substitution.
elimination or substitution or graphing for the system. So I would have to find the equation of segment DB. I would have to find the equation of segment AC, and then I would solve that system. Could you do that?
Yeah.
Yes. Would it give you the same answer? Yes. Would you spend 20 minutes doing the problem versus 20 seconds? Yes. Okay? Work smarter, not harder.
Okay, it works as well if you just have the midpoint of AC and DG because the midpoint is the same.
Simply because we already knew. Whoops, can't spell today. We were already given that information. This is the only reason we were allowed to do this is because we were told that quadrilateral ABCD was indeed already known to be a parallelogram. If we didn't know that it was a parallelogram, then what would we have to do? If you still wanted to use the midpoint, what would we have to do?
You have to
Prove
that
first
it's
is that prove that ABCD is a parallelogram.
Well, look very closely. Can I still use my midpoint?
Yeah. Prove diagonals facing each other.
So what would I have to do?
And the midpoint.
Of
Diagonals.
how many?
both.
One.
Both. And then do what with them?
That's true.
Then what would I have to do with both of them? What would I have to do with both of these midpoints?
You have to check if both midpoints are equal.
Yes.
If they are the same, okay? If I did not know that this was a parallelogram, if I just knew it was a quadrilateral, if I was trying to determine if this thing was a parallelogram, I would take both of my midpoints and of my diagonals. If I found the midpoint of both diagonals and they were the same, then I could say this thing was a parallelogram. Okay? But that's not what we were asking. We were given that this thing was a parallelogram, and then we were asked to find the point of intersection. Okay? All right. Any other questions out of that homework? Like I said, we went through the first page. The back page of that is really the only questions that we didn't cover. Do not lose this because we are going to finish these problems. Okay? Okay. All right. So we'll put that away. Now, oh, you did have a question? Which one? I'm sorry. Oh, you're trying to go ahead of the work. Yeah, that's why I told you not to do those. You didn't have those information.
I saw.
Oh, I know, but you haven't left for sightseeing. No, you're still here.
I saw.
Awesome. We're gonna see if it's gonna be right.
No, it's left.
No, there was a reason why I stopped on that first page, because the second and third page, you don't have the information to do. Right? Now, if you were an eager reader and you worked ahead, then that's fine. But, yeah. All right? And there's nothing wrong with that, because I only told you to do the first page. Now, what we're going to do today is we're going to switch. We're going to, instead of always being given parallelograms, we're going to switch those, and now I'm going to give you coordinates, and you're going to have to prove, based off of the coordinates, that it's a parallelogram. Right? All I'm going to give you is the coordinates, and you're going to have to tell me yes or no it is, or it is not a parallelogram. Okay? This is the start of us taking these coordinates, these four vertices, and that's describing each quadrilateral as a simple quadrilateral, a parallelogram, a rectangle, a rhombus, a square, a trapezoid, an isosceles trapezoid, or a kite. Hope we're paying attention. Okay? So by the end of this unit, I will give you four coordinates, the coordinates of the four vertices, and you will have to put the best place for the best classification of that quadrilateral. All I'm going to give you is the coordinates of the vertices. We will have to go through all the checklists that we will go through to best classify this thing. It's not hard, but it is time consuming. Okay. Now, before we get way into that, we gotta start small. Ready? All right. Here we go. I'm going to give you point P in the coordinates. It has the coordinates 0, 0. Point Q has the coordinates 3, 4. Point R has the coordinates 7, 4, and point S has the coordinates 4, 0.
I'll give you one and then hold.
Based off of the information that you already know, tell me whether this is or is not a parallelogram. Amazing. This is all you guys are going to do. Afraid Mr. Marsh is going to come back in? How many different ways do we have to do this problem?
One out of five.
One and one.
Yeah, you have five or you can only do one.
5. Do agree with having 5, but one of these is actually going to be a lot more work than any of the other 4. Which one is going to be very, I shouldn't say very difficult, more involved to prove that this is a parallelogram?
Prove both the opposite angles are.
Yes. By proving both pairs of opposite angles are congruent. Because if, in order to have that, I would even have to know the measure of the angles. Do I know the measure of the angles? No. If I don't have the measure of the angles, then how am I going to prove them congruent?
You have to use the distance formula to find it.
The angles?
No, the sides measure of the side.
So how's that going to prove that I have congruent angles?
Because the congruent angles. Well, you're talking about angles or sides?
Angles.
Oh, both pairs of angles are congruent.
We said that's going to be difficult. So can you think of a way that I could use that? Because I can. It's just going to be more involved. Anybody think of that one? Don't need a protractor.
Oh, of course, it's the sum of all the 3 angles are 360. In quadrilateral, opposite sides are the same angles.
Only it is a parallelogram.
Yeah, you
Can't assume that they're congruent. We got to prove that they're congruent. See, it's a little bit more involved, right? The way that I would have to do this one, okay? The way that I would have to prove both pairs of opposite angles are congruent is to first prove that I had congruent triangles. And then I would have to use CP/CTC to prove that the angles are congruent. But if I'm going to prove that the triangles are congruent, what's the only way that I can prove that the triangles are congruent, given the best way to prove that the triangles are congruent, given the coordinates?
Sides.
By finding the
Sides.
What about
distance of this?
the lengths of the sides. Well, if I find the lengths of the sides, you've already done this one. So you're doing more work than you really need to do. Okay, so I could prove it this way, but this one's probably not the optimal option. Could I prove that both pairs of opposite sides are parallel?
Yeah.
What would I use here? Slope. So one option is to use slope. So what is my formula for slope?
y2 minus y1 over x2.
Okay, so slope, I could use that. All right. Well, what am I going to use to prove congruency? Let's see CTC.
Size.
Distance formula. What is the distance formula?
Root square of
Root over x.
D.
x2 minus x1 equal to the power of 2 plus y2 minus y1 to the power of 2.
What did we say? Where did that come from? Do you remember where I told you that came from?
Pythagorean theorem.
Pythagorean theorem. Okay? I think that's what he said.
Pythagoras.
Yes. The derivation of your distance formula comes from Pythagorean theorem. Okay? Leg squared plus leg squared is equal to hypotenuse squared. The length of the hypotenuse is equal to the square root of the lengths of the sides squared added together. Okay, so that's where that came from. Well, if I'm going to use slope, I'm not going to use distance. What about proving the diagrams bisect each other? What would I use? So these are the three things that we are going to do. And that midpoint we already said is x1 plus x2 over 2, y1 plus y2 over 2. So those are the three formulas that we need to use for this coordinate geometry. All right? Who wants to tell me which method they use? What you got?
I did the parallel.
Both pairs?
Yeah, both
Okay. So what did you use?
I just found the slope.
How many times? 4 times. Okay. So we found the slope 4 times. Because, why? What do you know about parallel lines?
Yes.
Same slope. So if I find the slope and the opposite sides have the same slope, I know that those opposite sides are parallel, not congruent. Slope doesn't give me congruency. Okay? So I would find the slope 4 times. Did anybody use anything other than slope? Yes, the second one we wrote as, okay, so you use slope and what? For how many sides? 2 sides. So I still have 4 calculations, just 2 of them were slope and 2 of them were distance. Is that okay?
Yes.
Yes, as long as I use it on the same side. Did anybody do anything different? Yes. Find the midpoint. How many midpoints did you find? 2. 1 for each of the diagonals. And then what did you do with those midpoints? Check it out the same. Is one necessarily any better than the other?
No.
No, is it going to give you any more information than the other? No. Absolutely no different. The end result in all of these is that the quadrilateral is or is not a parallelogram. Okay? So, is this thing a parallelogram?
Yes.
Yeah? Okay. Passes all of our tests. Does anybody need to see this? Anybody like to see it? Well, I tell you what, let's do this one so that we get used with slope and distance. Okay? So then we can see that. Because we've already done the midpoint, so let's do this, and we'll see about the slope and the distance. So, very first thing that we want to do to help us out to get a visual is to what? What do I want to do first? Draw this thing. Okay, plot this thing out. Which quadrants do I need?
Well,
First one. Only need that first quadrant. Okay? So we're looking at the point P, which is here. We're looking at the point Q, which is 3, 4, so that's somewhere around there. Looking at the point 7, 4, so that's further out here. That's R, but on the same vertical as Q. And then we're looking at S, which is in between Q and R on the x-axis. And there's S. So we're looking at something like this. Kind of looks like a parallelogram, but I can't go by the way it looks because I didn't use any tools to get this. This is just a quick sketch, so I can't go like this. So, one pair is both parallel and congruent. Ricky, you did this one.
Yeah.
I mean, which pair of sides did you talk about?
same with QR.
Okay, so segment QR and segment PS. Now I'm going to go through this whole thing a little bit longer than you really need to in this one, but it's an over-exaggeration of the problem. So the very first thing is we're going to show parallel. Okay? Parallel. Well, that means that we need to find the slope of segment QR. Go over here, y2 minus y1. What's y2? 4. 4. 4 minus 4. 4 minus 4 over 7 minus 3. 4 minus 4 is 0 over 7 minus 3. 4. What's 0 over 4? Zero. Okay. So now we need to go, if we're doing one pair of opposite, what's the side that is opposite to segment QR? Segment PS. So we got to do the same thing for finding the slope for segment PS. So what's y2?
0.
0. Minus?
0.
Over?
4.
Minus?
0.
0 minus 0. Hard one.
0.
All right. 4 minus 0.
4.
4. Well, that's 0. Are they the same?
Yes.
So if they're the same, what does that tell us? Parallel. Yes, ma'am.
For all of these, we need to actually sketch out the polynomial form.
Unless you can visualize it in your head.
Yeah, because you said you might make some points, so I was just wondering, you can't.
I'm not, if you don't show this, you're not going to lose your marks. Okay? If you can take those coordinates and you can visualize them in your head where they are, where they need to be, which segments are opposite to which, perfectly fine. This is just to help us. This is worth really nothing.
All of those methods don't work if you don't know if the opposite don't work.
Correct. Okay? So now we've got the parallel part. Now we need to check congruent. Okay? Well, to check congruence, we said we're going to find the distance. So now we got to find the distance between Q and R. X2 minus X1, what's X2?
7.
7 minus?
3.
7 minus 3 squared plus
4 minus 2.
4 minus 4 squared. Well, 7 minus 3? 4. 4 squared? 16. 4 minus 4?
0.
0. R was 0 squared.
0.
0. 16 plus 0.
16.
Square root of 16. Leave it. I know you do, but leave it. Okay, there is a reason. There is a method to what I'm telling you. Okay? So we did Q to R, but now we got to do P to X. Okay? Same thing. What's X2 minus X1 for segment PS?
4 minus 0.
4 minus 0. Okay, 4 minus 0 squared plus
0 minus 0.
0 minus 0 squared. 4 minus 0?
4.
4. 4 squared? 16. 0 minus 0, 0 squared, 0 plus 0, so that's the square root of 16. Yes, I know. I'm going to stop here. Yes, I know that the square root of 16 is 4. But what happened if that came out to the square root of 17?
And then you will be good.
Would you?
Yeah.
I guarantee 90% of you would have given me a decimal. Wouldn't you? Oh, you're all fit.
It's been
Okay, trust me. It's
been
been about 2 months now. I know that you would have given me a decimal. You know how I know?
Test.
Because on that first point, instead of giving me 5 over 2, you gave me 2.5.
Who did?
Separate.
Somebody,
Okay? See? You guys are paying attention. You don't even know I'm paying attention. All right. So yes, there's no reason. If we're just checking to see if it's the same value, we're not, again, I'm not assessing whether you can do radicals or whether you can't do radicals. I'm assessing whether you can determine whether this thing is or is not congruent. And all you have to do is look at the end result. Compare that last radical to that last radical. Is the square root of 16 equal to the square root of 16? Well, better, you're taking the square root of the same number. So, congruent. So now, we've got a pair that is parallel as well as congruent. Is this thing a parallelogram? Yes. Okay, now, I'm going to show you a really easy way to do this problem. don't forget, your slope is also rise over run. How much rise do you go from Q to R? 0. It's all run. 0 over some number. How much rise do you go from P to S? 0. How much do you run? 4. Okay, 0 over a number. I got my slope without even doing the calculation. Done. Now, you chose these two very easily. Since there is no rise, I can count. How far is it from 3 to 7? 4. 4, 5, 6, 7. 4. How far is it from 0 to 4? 4. So you can get this very quickly, very easily, because it's set up very nice. Doesn't always work out that way, but in this case it does. Right? Let's get it off.
Someone's neck.
No, because I heard it sounded.
Kevin's lying. It's all right. That's where I keep my ghosts. It's fine. I wouldn't. He's kind of bad.
Just take it out.
Okay, so now you know how to do it. Let's see. Let me give you a couple other ones. Problem number 2. Looking at the point A, -2, 1. Looking at the point B, 1, 3. C has the coordinates 2, 0. D has the coordinates -1, -2. Third problem, N is the point 2, 5. O is the point 3, 3. T is the point -2, -3. And E is the point -3, 1. Determine if those two quadrilaterals are or are not parallelograms. I don't care which method you use. If you want to use the same method twice, I really don't care. I am assessing you whether you can determine if this thing is or is not a parallelogram. I don't care what method you use. Does that make sense? Perfect, go. Quickly. Don't fall in. Oh, sorry. Just had to make sure you guys were with me.
What if you got a heart attack?
Well, then, we're gonna have to
You
get
have no hearts. Because you have something you don't do.
especially if it's a theory.
That's not good. But then that's it happening.
English, man, English. Come on, let's go.
I hear a laugh. They should have a laughing competition.
What is that?
It's a high kick.
It's a lot.
What?
We got number 2 done yet? Anybody not done? Still working? Everybody still working on number 2? Okay. Who's got number 2? Yeah? Almost? Almost. All right. All right. No, those people work. Your friends. Oh, you got number 2? Just curious. Did you do number 2 the same way you did number 1?
Yes.
How many of you guys changed methods? How many of you guys did something else but then followed this method for number 2? Or maybe did this one for number 1 and did something different for number 2? Just curious. It has absolutely no meaning. Just curious for me.
Are you ever going to give us a quadrilateral that's not a parallel?
Sure.
No, I mean like, we have to find it is parallel. Could it be so uncertain?
Yes. I know what you're yes. Okay, number 2 is that a parallelogram?
Yes.
You sure about that?
Yes.
Oh, no, it's not.
Uh-oh.
It's
All right. Well, we must obviously have a debate. The only way to solve the debate or settle the debate is to actually do it. All right. So we did this one. Let's check this one. Okay. Let's determine if the diagonals bisect each other. So if can't do those points. If we are looking at the point -2, 1. Just pay attention. Are we paying attention? We're looking at -2, 1. We're looking at 1 and then 3. That's B. C is 2, 0. And -1, -2. So we are looking at, if we are going to prove that the diagonals bisect each other, I'm looking at the midpoint of segment AC, and I'm comparing that to the midpoint of segment BD. Okay, so segment AC, well that's -2 plus 2 divided by 2. 1 plus 0 divided by 2. -2 plus 2, hard one. 0. 0 divided by 2. 0. 1 plus 0 divided by 2. 1/2. Okay, so you have to, there's that 0.5. Okay, now segment BD, same thing. -1, excuse me, 1 minus 1 over 2. And 3 minus 2 over 2. Still want to think, go? Against the Korean? What's 1 minus 1?
0.
0. What's 0 divided by 2?
0.
0. Uh-oh.
But,
3 minus 2 over 2. 3 minus 2 is
1.
1. 1 over 2. Uh-oh. Oh, what are you calling about? You copied off his paper. You know nothing. Okay. Guaranteed, if you made a mistake, most of the time your mistakes are in the arithmetic. Arithmetic. Okay. The adding, the subtracting, or even more common is switching your x's and y's. So be careful. Put the x's and y's in the right place. Okay. All right. Always gonna miss.
Yeah.
Just kidding. All right. So, how about number 3? Did we get number 3 done?
Yes.
It's not
Not a parallel.
I got it.
You want to do that? You want to do that again?
That's the one that's not a parallel.
2 0.
Oh.
2-0.
Do we want to go through number 3 as well?
No.
Great. All right. So that's how we prove that a quadrilateral is a parallelogram. Okay. We find one of these 4. We could use 5, but the one is going to be a little bit more. This guy right here is the one that we can kind of ignore. So if we're coordinate-wise, choose one of these 4 and go with it. Get very familiar with one of those 4. Use that, because that's the one that's going to propel you into the next step, because this is only the first step of the whole process. Because now I'm going to change it, and I'm going to say, not if it is a parallelogram, but if it is a rectangle. So, y would be 2, 4, and z will be 3, 0. Now, before we get carried away, we've got the 5 ways to prove that it's a parallelogram. How would I prove whether this thing's a rectangle? Well, what's a more geometric way to say the corners are 90 degrees? What happens at the vertices? What do you know about the sides?
Perpendicular.
What are? The angles or the sides?
the sides.
The side. Okay, so to prove that it is a rectangle, but that was little man. So be worried about that. Prove which side. There we go. Prove consecutive sides are perpendicular. How do we prove perpendicular? Negative reciprocal slope. So we would come back over here and we would talk about the slopes. Yes, what's your question?
Is it rectangle parallelogram?
Is it? Are you asking me or telling me?
So isn't that?
Tell us. Keep telling yourself.
Isn't the 5 ways to prove that parallelogram also applies to the rectangle?
Yes. So to take this to the next step, what do we have to do in order to prove that it's a rectangle?
You can also use the ways to prove the.
Not also.
You can.
I don't know. Yeah. The angles.
Forget that.
Yeah.
Why do I have to?
First you have to prove it's a parallelogram. Then you have to prove it's right.
Yes. To prove that it's a rectangle, the very first thing I have to do is make sure it satisfies one of these 5. If it satisfies one of these 5, then I can go to this and say that, and I'll tell you the 2. Either prove that consecutive sides are perpendicular, Or what? What's another special characteristic of a rectangle?
They have right hand.
Can't be all four sides.
No, like both parallel sides.
You mean prove that it's a parallelogram?
No, like.
The diagonals are the diagonals are congruent.
Right? So the other piece, the other special part of a rectangle is to prove the diagonals are congruent. So we've got to first choose one of these four to make sure that that thing is a parallelogram. Because is there any need to check these if it's not one of these? No, because what's the definition of a rectangle?
It's a parallelogram with right angle.
Yes. So first has to be a parallelogram, then we do this. So to determine if it's a rectangle, so what I probably should do so there's no confusion is change these. Renumber these. So that it is a rectangle. First thing is prove it is a parallelogram. And then prove one of those. So it's a two-step process. First prove it's a parallelogram. Then, do I need to prove both of these? No. Just like I don't need to prove all 5 of these, I only need to prove one. Over here, once I got it to be a parallelogram, then I'm either going to show that the consecutive sides are perpendicular by comparing the slopes, or I'm going to show that the diagonals are congruent by looking at the distance from you. Okay? So there's that. Go.
What is one?
It's like
What are they doing?
stop making this.
We would like to go through this together. There is a trick to this process, if you think about it. Of course, give a free homework pass to the person that can tell me the trick.
So that's meaning they gave us like close to 5 minutes.
So what does that mean?
So that you know that they're not
Okay, well that's what we wrote up there. That's not very tricky.
no, the slope has to be negative after you prove that it's parallel.
very close. Think about that. How would you prove that it's a parallelogram?
So by using the both, prove that both pairs of opposite sides are parallel.
So the trick to this is to do what?
Find the slope of
Good catch, yeah. Just kidding.
Oh,
Okay, free over guys. Keep that in mind. Okay, good job. Yes, by simply going to this, right here, what do I have to do here?
Find the slope
Why?
so that you can prove that they're parallel.
How do I know that they're parallel?
If the opposite sides have the same slope, then they're parallel.
Okay. Well, what does that have to do with proving that it's a rectangle?
If you use the first way, you have to prove that the consecutive sides are parallel. I mean perpendicular,
Which includes.
which includes the slope.
So how many extra calculations do I need to have?
You just need to find the slope for the
Well, we already did.
four sides at the beginning.
So how many extra calculations do I need to do?
2, 4, 1,
3, 0.
0, 30.
That's why it's the trick. Because if I find the slope of all four sides, I can look at the ones that are opposite, then they have to be what? What about the slopes?
Negative reciprocal.
For the ones that are opposite, what do you know about the slopes? They have to be the same. Now, if I don't have to do any other calculations because I've already got all four of my slopes. Now I look at the ones that are, careful. Now I look at the ones that are consecutive and compare those slopes. So, what we want to do, what's the very first thing that I have to do?
Draw it.
Sketch this thing out. So, -3, -2, that's somewhere down here. That's W. -4, +2, that's X. 2, 4. Let's see, that's Y. And 3, 0, that's Z. So now, I need to find the slope of what sides? So I need to find the slope of what?
XY.
Segment XY.
Segment
Segment slope of
Y.
segment. We're going to go opposite. I'm going to do this initially. Well, we'll do it either way. Segment YZ. Fine, no worries. Same way.
Segment W.
Slope of segment WZ.
And slope of segment XW.
Segment XW. Okay? Now, we find the slope. Segment XY. What's Y2?
4.
4 minus 2 over 2 minus -4. The words mean not that. It's not locked. If somebody wants to come in, they can certainly come in.
Come in.
Can I please order waiting for like 2 seconds?
2 seconds.
God, this is
Two.
too.
Okay, that's enough.
Great. Okay, so what's 4 minus 2?
1.
2. 2 plus 4. 6. 2 over 6. 1/3. So now we find the slope of segment YZ. Well, what's Y2? 0. 0 minus 4 over 3 minus 2. 0 minus 4 is over 1 -4. Okay? Now, to be honest, probably perfectly fine to leave it right there. Leave it as a fraction. You're comparing slopes. It probably is going to be easier for some of you to look at these quickly. Okay? Segment WZ. What's the top? What's the numerator?
0 plus 2.
0 plus 2 over
3 plus 3.
and that reduces to
1 over 3.
2 over 6, which is 1 over 3. Segment XW.
4 minus 2.
Okay, segment XW. Segment XW is
XW.
yep, right here.
-2 minus 2.
-2 minus 2 over,
-3 plus 4.
and we get Okay, so now, first thing to do is to check both pairs of opposite sides parallel. Do I have two pairs of parallel sides? So is it or is it not a parallelogram?
It is.
It is a parallelogram. So the first part is good. So the thing that we have to check, parallelogram. Yes. And then we need to check rectangle. Well, pay attention. This is where the trick comes in. If you did this, if you calculated the slopes, I don't need to do any further information because I can prove that consecutive sides are or are not perpendicular. If it's a rectangle, they are perpendicular. What does it mean to be perpendicular? Negative reciprocal slopes. Is r 1/3 and -4/1 negative reciprocals of each other? No. So are these consecutive sides perpendicular? No. So it's a parallelogram, yes, but it's a rectangle, no. Make sense?
Maybe.
So,
Someone says what they want.
All right.
That's just.
No, it's not Justin. What do you guys think?
That's
You said just
Yeah, it's Justin.
All right, here we go.
What is just in the.
Pay attention. So now, same thing. Is this thing a rectangle? L has the coordinates -6, 3. A has the coordinates 0, 6. C has the coordinates 2, 2. And K has the coordinates -4, -1. Determine if that thing is a rectangle. Very good.
Guys.
All right, Chelsea. All right, Ricky. Make this, everybody else know.
Ricky. I finished my homework, so I don't care.
I didn't hear you.
That's just.
Yeah, I really just.
Wait, do I have to do it?
Everybody else go.
Shoot. No, do I have to do it? Okay, then. You want
No, I don't need to.
Ricky, do it.
Yeah, do it. Throw it to Emma so she can.
Throw it to Emma.
No.
Oh!
Ricky.
One more time.
He's gonna hit my projector.
He
did
did
it last
Okay, here we go.
Everyone should get it right.
Is this thing a rectangle?
No. Yes. Oh, yes. Yes.
Is it a rectangle?
Yes.
Do we agree? Yes?
Yes.
All right, so to prove that we have a parallelogram, choose one of these four and get it done. To prove that we have a rectangle, the best option, the one that is going to get you there the fastest, is to prove that the both pairs opposite sides is parallel to get the parallelogram. If they're not parallel, there's no need to check that. They're perpendicular. Because if they're not parallel, then it's not going to be a rectangle. So use this, get it there. You do prove that it's a parallelogram, then look at your slopes again and see if they are negative reciprocals of each other. Okay? All right. Now, all of this is building up to one thing. And that one thing is, now, instead of me being very specific, determine if each quadrilateral is a parallelogram, if it is a rectangle, if it's a square, if it's a rhombus, if it's whatever. Now, I'm not going to give you that. I'm going to just simply say, give the best classification
How do you do this?
of each quadrilateral. Okay, now, so far, we're only dealing with parallelograms. So we've got whether it is a whether the quadrilateral is or is not a parallelogram. Then we're going to say, okay, whether it is or is not a rectangle. What's the other one that we're going to have to check for? Parallelogram.
Rectangle, square.
Okay. Check for the rhombus. Why check for a rhombus? Okay, so if we check for the rhombus, is the rhombus a parallelogram?
Yeah.
Yes. And we said that the rhombus then is, so we first prove that it's got to be a parallelogram, just like a rectangle. Then we have two options. Prove that instead of saying all four sides are congruent, we can say that, what's a fancy word for the same one? Consecutive sides congruent. Where's my eraser? Okay, so we want to prove consecutive sides are congruent. Or what's the other special case, or the special characteristic of a rhombus? Yes. Okay. So, first we still have to prove that it's a parallelogram. If it's a parallelogram, then we can check whether it's a rectangle. If it's a rectangle, are all rhombuses rectangles?
No.
Can a rhombus be a rectangle?
Yes.
What happens when the rhombus is a rectangle? So if both of these happen, then whoops, that's right. They make a baby, and that baby is a square. Okay? So, what's going to happen is if we prove that it's a parallelogram, then we prove that it's a rectangle, and then we try to determine whether it is a rhombus. If we get a yes, a yes, a yes, is there anything else that I have to check to make sure it's a square? No. If your yes is all the way down, it's a square. So the way that this works, okay, start with a quadrilateral, and then you end up with a parallelogram. Okay? And that's where we stop. Okay? Sometimes they're going to be, sometimes they're not even going to get that way. Quadrilateral. Okay? So we're going to check with a quadrilateral, and then we check the parallelogram. If it's not a parallelogram, at this point, that's as far as we go. Then yes, we're going to have checks for trapezoids and kites, which are a little bit different. But here's our hierarchy. Check for quadrilateral. If you're given 4 vertices, you know it's a quadrilateral. Nothing really to check there. So really the only first check is to see if it is or is not a parallelogram. Okay? If you get that, if you get a yes here, and then you get a rectangle, then you know it's going to be a rectangle, right? Check for that. Or it could be check for a quadrilateral, and yes, we get a parallelogram by, checking for the parallelogram. Then we can get a rhombus. Okay, and I guess I could check this. Rectangle, yes. Rhombus, no. The result is what? A rectangle. Okay. Rhombus, yes. Rectangle, no. What's the result? A rhombus. Okay. Then if we start with a quadrilateral, then we go to a parallelogram, and then we go to a checking for a rectangle, and we get a yes, and then we go to the rhombus, can't spell right, and we get a yes. Then we know that if we get a yes for the parallelogram, a yes for the rectangle, a yes for the rhombus, then our result is a what? Square. Okay.
Love that expression.
Parallelogram, yes, then the result is right? So I put the finishing touches on. We know that we're going to be given a quadrilateral. If I check for the parallelogram, I know the best I can say it's a quadrilateral at this point. If we start with a quadrilateral and we get a parallelogram test says yes, then the result is a parallelogram. Then we check for the parallelogram. Is it a rectangle? Yes. Then we check for rhombus. No. Then the best it's a rectangle. And on and on and on. Okay? Now, here is your homework. So, give the best classification for Q, which is the 0.35, U, which is the 0.31, A, which is the -1, 1, and D, which is the -1.5. Second one is Q, which is the -512, U, which is the 5, 12, A, which is the -1.4, and D, which is the -11.4.
Can you just
Squeeze this in there.
Oh.
Q, which is the -6, -1, U, which is the 0.4, -6, A, which is the 0.25. You guys are really lazy. And then D, which is the -8, 10. 4 more. Oh my gosh. 2, -4. U, -6, -8. A, which is the -10, 2. And D, which is the -26. 4 problems. Oh my goodness. Okay?
Oh, I see what you did there. What did he do? Quad. Quad. No, he ate. The points are quad. Quad. Oh.
Sorry, I ran out of space.
Comprende,
Thank you. Okay, so you got 4 homework problems. Go through the whole check. Your best, you're trying to give the best classification. If the best classification is quadrilateral, that's the best classification. If the best classification is a parallelogram, so be it.
Oh, are you faking that?